Hello everyone, and welcome back to MLS 327. In this video, we will be working through an antibody identification problem together. This video should be watched after you have already watched the recorded presentation on antibody detection and identification. So you should have a good background of the information needed to apply to this problem set. There will be questions embedded where you can pause and answer the questions on here. They will be for self-assessment to see if you're understanding, and that you could ask questions from me via email or during office hours if you are not. Also, this should be watched before you attempt to solve your problem-based learning set assignment for antibody identification case studies. This is the fun part about blood bank. Antibody identification, and we will be looking at more complex antibody problems with multiple antibodies and other issues in the next course, MLS 421. For now, we will stick with basic, simple, and single antibodies. So you will apply the strategies that you learned in the previous presentation for ruling out, and the rules we'll use, which I'll reiterate here, as well as using the rule of 3 to statistically validate that you have identified the appropriate and correct, accurate antibodies in the patient's plasma. So here we have some information about a patient. I've made this up. You'll see that this screening antigram looks a little bit different than you're used to looking at if you've worked in a blood bank for antibody identification and screening, because I make these up myself so that they're accessible to all learners. They have the same information, they're just a little bit different looking, the style. The patient's name is here, her medical record number, her date of birth, her ABO and D blood group type that we established in a previous forward and reverse blood group typing. The antibody identification and other antibodies not ruled out is left blank because that's what we'll be determining here. And we do have a history on her. She's received 2 red blood cell transfusions and has had 1 previous pregnancy. So she's had 3 previous exposures to foreign red cell antigens that her red cells may not express. Remember, in order to develop clinically significant antibodies other than in the ABO blood group system, you need to be exposed to those antigens, either on your own cells if it's an autoantibody, or other human cells via transfusion, pregnancy, or transplantation. Okay. So let's first look at the antibody screen called an antigram. Okay. On the right over here in blue, you see the phases of reaction. We are using test tube here. I realize that most institutions use gel or solid phase, which does not look at room temperature or immediate spin reactions because they're just trying to find IgG antibodies. But for the sake of educational purposes, we are going to differentiate between cold and warm reacting antibodies. We're also using polyethylene glycol, otherwise abbreviated as PEG, as our enhancement media. And this CC refers to your IgG-coated check cells or your COOM cells, okay, which are only used as an internal control to make sure you added anti-human globulin or anti-IgG to the tube. Okay? So only cells that are non-reactive at this AHG phase do you add these IgG-coated check cells as an internal quality control, so to speak. So these pluses and zeros along here, we have 3 different reagent cells. They're all type O. The first 2 are OD pos. The third one is OD neg, as stated here, little r. But they're all type O because we don't want to detect anti-A or anti-B in the patient's plasma. Those are expected antibodies, and we've already identified those in our reverse blood group typing. So we use type O because they don't express A or B antigens, and we don't want to detect anti-A and or anti-B in the patient's plasma. We want unexpected, preformed, clinically significant antibodies against red cells. Okay? So the pluses and zeros indicate whether that corresponding antigen, if it's a plus, is expressed on that cell. If it's a zero, that antigen is not expressed on that particular reagent cell. So for instance, cell number 1 expresses or has the big D antigen on its surface, the big C, but does not express the little c or the big E antigen. Okay. Notice how I'm just using the letter big E, little e, big D, P1. That means antigen in blood bank and transfusion medicine lingo. If you're referring to an antibody, you must use the prefix anti, A-N-T-I, before the word to indicate that you're referring to an antibody, not an antigen. Okay. So using our established rules of rule outs, or some people say cross outs, you need to use cells that are non-reactive in all phases. The check cells are not a phase of reactivity, they're a control, so cell 2 and cell 3 can be used. Now we cross out the letter, but we are ruling out antibodies against that antigen. We are not ruling out antigen. Okay? So let's start by using cell 2. Our patient did not react with any of these antigens expressed on cell 2. The other thing you need to remember from the previous presentation is that the blood groups that exhibit dosage for our purposes in this course will be the Duffy, FYA, FYB, KID blood group system, JKA and JKB, and the MNS. So M in N and big S and little s. To rule out antibodies against antigens in those blood group systems, the antigen needs to be expressed in the homozygous state, meaning that that person, so cell number 1, expresses the Duffy B antigen, but not the Duffy A. That means that individual inherited 2 alleles for the Duffy B antigen and none for the Duffy A, so that's said to be Duffy B homozygous. The converse of that, cell 3, is Duffy A homozygous. Cell 2 is Duffy A, Duffy B positive, so it's heterozygous. They inherited an allele for the expression of each of those antigens, therefore you could not use cell 2 to rule out either of those antibodies. Okay. If you are still struggling with that concept, please go back and review that information in the previous video or in your textbook. It has to do with allelic combinations and genetic inheritance of the alleles for those blood group systems. So let's go to cell 2 and start using our rule outs. And you can stop here, pause the video here, and perform your rule outs. If you've printed this out, you can use the printout, or you can do it, just write it down on a piece of paper what you've ruled out. Right, welcome back. I'm going to perform my rule outs here. Okay. So what antibodies were you able to rule out using cell 2? Anti-big D, anti-little c, anti-big E, anti-little k, anti-Lewis B, LEB, anti-P1, anti-M as in Mary, anti-big S, anti-Lutheran B, LUB, and anti-XGA. You want to pause again here and use cell 3 because that did not react with our patient's plasma in either phase, and do the same process. Once an antibody has been ruled out, you don't need to re-rule it out, so 1/ is enough here. Welcome back again, and we will perform our rule outs using cell 3. Little e has been ruled out, anti-Duffy A, because that cell expresses A antigen only and not the Duffy B, so it's homozygous for Duffy A. Anti-JKA, anti-Lewis A or LEA, anti-N as in Nancy, anti-little s, and that's all. So pause again here and circle or highlight or underline, however you want to mark it, what antibodies you have not ruled out. We still have a fair number. Now, if your antibody screen didn't react, none of the cells reacted with your patient, you would be done. But that isn't the case here. So we're going to perform an antibody identification panel, which is the same methodology all type O reagent red cells, but just more cells. It will give you increased variety in the phenotype, more antigens that the cells express and don't, so we can narrow this down to one antibody to identify. So this is your antibody screen. The last cell here says PC for patient cells, auto control. So that there is the patient's plasma tested against their own red cells. Patient's plasma did not react with their own red cells, meaning that they have alloantibodies, antibodies directed against red blood cells of another human, but not autoantibodies. They don't have antibodies directed against their own red cell antigens, which is a good thing. Autoantibodies are not fun to work up in the blood bank, and they oftentimes can cause a lot of issues in the patient as well. Okay. So here we see our patient reacted with panel cell 1, 2, 5, and 9. So we cannot use those cells to perform rule out. I didn't do it here, but what you would want to do is just transfer these slashes from your screen to your panel, because again, once it's ruled out, you don't need to rule the antibody out again. So use the same mark to put your slashes there, and then start by using cell 3, then 4, then 6, 7, 8, and cell 10, and see what else you can rule out. Before you pause, I would suggest using either a different color or a different mark on the panel so that you know exactly what antibodies you ruled out using panel cells versus screening cells. Also, if you ever make an error, you don't have to start all over again. So pause and perform your rule outs, and then see what antibodies you have not been able to rule out once you use all the appropriate cells to perform rule outs. All right, we're back again, and I will perform my rule outs on here, and I've used a different symbol on here. I've used this. Okay, so here on cell 3, my patient did not react with cell 3, and that cell expresses Duffy B, but not Duffy A antigen, so it's homozygous for Duffy B, and my patient did not react with that cell, so therefore I can be sure that my patient does not have anti-Duffy B antibodies. Then we can rule out an anti-JKB, again using the same rule for dosage, and we can look at cell 6. JKB antigen positive, JKA antigen negative, meaning homozygous for JKB. My patient did not react with that antigen, therefore we can rule out anti-JKB. And the last one that we can rule out using cell 7 is an anti-big K or anti-Kel. That cell expresses the big K antigen. We don't have to worry about zygosity for our purposes in this class. So we can rule out antibodies against K. That in combination with what you've ruled out in your screen, pause here and consider what antibodies you do not have left that are possible circulating in the patient's plasma. Okay, now we want to look at our pattern of reactivity, and hopefully you've identified the antibody that is circulating in the patient's plasma. Okay. So on cell 1, that screening cell expresses the big C antigen. Our patient reacted with it. Cell 1, 2, 5, and 9 on the panel all express the big C antigen, and our patient reacted with 2+ strength of reactivity with all 4 of those cells. So we have reached part of the rule of 3, right? We have 5 cells that express the antigen that our patient reacted with. We need a minimum of 3. We also need a minimum of 3 reagent cells, screen and or panel, that do not express the big C antigen and our patient did not react. Now that does not mean our patient doesn't have an anti-big C circulating, there's just no antigen expressed on that cell for them to react with. And you can see that cells 2 and 3 on the screen are big C antigen negative, as well as cell 3, 4, 6, 7, 8, and 10 on the panel, and our patient did not react with any of those cells. So we have 1, 2, 3, 4, 5, 6, 7, 8 cells that meet that part of the rule of 3 equation. We needed 3. This is what I would call a perfect pattern of reactivity, where every cell that expresses the corresponding antigen that we think our patient has an antibody against reacted with our patient, and every cell that lacks the antigen does not react. We will see in our next course, MLS 421, that that's not always the case when you have multiple antibodies, when you have autoantibodies, or when there might be something else going on because of some medication or disease state that the patient is on or is experiencing. But for now, we have identified, and hopefully you've done that on your own, an anti-big C. So up here you would write anti-big C. Again, you need to have the prefix anti. Now I want you to pause one last time, and, well, one more time after this, and think about what other antibodies have we not ruled out. There are a couple of them. All right, and you'll be given the answer to that on the questions. And the last thing that I would suggest that you do is to calculate your p-value, the probability value, using the equation that was in the last presentation or in your textbook. So if you want to pause and calculate the p-value and then answer the question posted. If you have any questions regarding this information, or if you still have concepts that you're not sure if you're fully grasping about antibody screening and identification, please either email me or email me to schedule an appointment. And now, if you're finished with this, you should be able to start and tackle your problem-based learning set for the antibody identification case study. Thank you.